Today's class we will discuss transform of nth derivative of f of t. Um, so we know what is Laplace transform. A Laplace transform of a real valued function f of t is defined as integral 0 to infinity e power minus st f of t dt, provided the integral exists. So if you say Laplace transform of a real valued function f of t exists, it means we can Laplace trans we can talk about derivatives of f of t. If you say that Laplace transform for real valued function exists, it means we can talk about Laplace transform of nth derivative of f of t. So Laplace of fn of t is defined as s power n L of f of t minus s power n minus 1 f of 0 minus s power n minus 2 f dash of 0 etc. minus fn minus 1 of 0. So if it is nth derivative, it starts with s power n and ends with fn minus 1. You observe the pattern. If it is fn of t, starts with s power n and ends with f power n minus 1. So if you take n as 1, Laplace of f dash of t is s into L of f of t minus f of 0. If you take n as 2, that is Laplace of f double dash of t, second derivative of f of t is s square f of s minus s into f of 0 minus f dash of 0. If you take n as 3, that is Laplace of third derivative of f of t is s cube f of s minus s square f of 0 minus s into f dash of 0 minus f double dash of 0 and so on. So by heart this you will be using in problems. You should remember the Laplace transform of f dash, f double dash and f triple dash. Now next comes transform of the integral 0 to t f of t dt, that is 1 by s f of s or 1 by s L of f of t. So you don't have to learn for both the properties. It's enough if you remember the statements. So using Laplace transform of cos at, find the Laplace transform of sin at. Whenever you have the question starting with using Laplace of something, find the Laplace of something else, it means you have to use Laplace transform of derivative. I repeat, whenever you have the question starting with using Laplace of something, find the Laplace of something else, it means you have to use Laplace transform of derivative. So write the first derivative. Laplace of first derivative is s into f of s minus f of 0. So f of t is cos at. You have to use this. So f of t is cos at. F dash of t is minus a sin at. So substitute for f of t and f dash of t. What is f dash of t? Minus a sin at. What is f of t? Cos at. So Laplace of minus a sin at is s times Laplace of cos at minus f of 0 is cos 0, 1. So Laplace of cos at is s by s square plus a square. When you simplify, if you take a to the right side and simplify, you will get Laplace of sin at as a by s square plus a square. So you remember, whenever the question starting with Laplace of something, using Laplace of something, find the Laplace of something else, take f of t with whatever you have to use and find f dash of t and substitute in the formula. You will get the Laplace transform of whatever is asked. The second question, prove that Laplace of f dash of t is s into f of s minus f of 0. Start with the definition. Laplace of f of t is integral 0 to infinity e power minus st f of t dt. In place of f, you have f dash. So integral 0 to infinity e power minus st f dash of t dt. So integrate by parts. First function e power minus st. Second function integral of f dash. When you integrate, the order will reduce. So integral f dash is f. So first function into f of t, that is e power minus st into f of t from 0 to infinity minus integral t equals 0 to infinity f of t into derivative of e power minus st, that is minus s e power minus st dt. So when t takes upper limit infinity, e power minus infinity is 0. So minus f of 0, minus of minus plus s times integral 0 to infinity e power minus st f of t dt. So this integral is nothing but the definition of Laplace transform. So s into f of s minus f of 0. So Laplace of f dash of t equals s into f of s minus f of 0. That's how we get the formula for first derivative of f of t. Now we have a problem from integral. If you have to find the Laplace of integral 0 to t e power minus t sine 4t dt. So what is the formula? Laplace of integral 0 to t f of t dt is 1 by s f of s. In place of f of t, t e power minus t sine 4t dt. And what is f of t here? This product. So whenever you have a product and if it contains an exponential term, it means shifting property. Whenever you have a product and if it contains an exponential term, it means shifting property. If you have a negative exponential, it is f of s plus a. So here it is f of, what is a here? 1. So 1 by s f of s plus 1. So 1 by s f of s plus 1 is the answer. We have to get f of s plus 1 through f of s. What is f of s? L of f of t. What is f of t? T sine 4t. And what is Laplace of t f of t? T f of t. What is Laplace of t f of t? Minus f dash of s. What is Laplace of t f of t? Minus f dash of s. So Laplace of t sine 4t minus 1 f dash of s, that is minus 1 d by ds of f of s. What is f of s? L of f of t. What is f of t? Sine 4t. So minus d by ds of Laplace of sine 4t. What is Laplace of sine 4t? 4 by s square plus 16. So minus d by ds of 4 by s square plus 16. So if you differentiate using quotient rule, you will get minus 2s by s square plus 16 the whole square. On simplification, you will get 8s by s square plus 16 the whole square. So 1 is 1 by s f of s plus 1, or 1 by s into 8 times s plus 1 by s square plus 16 the s plus 1 whole square plus 16 the whole square. If you say f of s is this term, f of s plus 1, you just have to replace s by s plus 1. So f of s plus 1 is here. So what is the answer? 1 by s into f of s plus 1. So 1 by s into this term. Now next one, similar problem. Find the Laplace of integral 0 to t cos a t minus cos b t by t dt. What is the formula? 1 by s f of s. What is f of s? L of f of t. What is f of t? Cos a t minus cos b t by t. And now if you see this ticked one, what is it? It is of the form f of t by t. It is of the form f of t by t. What is Laplace of f of t by t? Integral s to infinity f of s ds. So integral s to infinity f of s ds. What is f of s? L of f of t. What is f of t in the ticked one? Cos a t minus cos b t. So what is Laplace of cos a t? S by s square plus a square. What is Laplace of cos b t? S by s square plus b square. And what is integral of these two? Half log of s square plus a square here minus half log of s square plus b square. Half is taken out from s to infinity. So you have log a minus log b is log of a by b form with the limits s to infinity. So log of a by b with upper limit infinity is 0. I have told you, whenever you have log a minus log b or log of a by b with upper limit infinity, it is 0. So it will exist only for the lower limit. So minus 1 by 2s log of s square plus a square by s square plus b square, or 1 by 2s of log of s square plus b square by s square plus a square. So you should remember these two integral formula. Integral x by x square plus a square dx is half log of x square plus a square. We have used that in this problem. In place of x you had s, and this is integral dx by x square plus a square is 1 by a tan inverse of x by a. Now we will get into inverse Laplace transform. See, when you say Laplace transform of a real valued function x, it means we can talk about its inverse. See, any concept has the inverse. If you take addition, it is subtraction. Repeated addition is multiplication. The inverse operation is division. So every concept in mathematics has the inverse. If you say y equals f of x in function, then x equals f inverse of y. So No, inverse exists in case of transforms also. You have learned inverse Fourier transform, inverse Z transform. Similarly, you have inverse Laplace transform. So, if the definition is very simple, if L of f of t equals f of s, it means f of t equals L inverse of f of s or L inverse of f cap of s. So, when you take Laplace, you take a frequency function. When you take the inverse, you get a time valued function. Laplace of time valued function is frequency function. Inverse of frequency function is time valued function. So now, so to know inverse, to understand inverse, you should be thorough with the Laplace transform definition and all the standard functions and the properties. Only if you're thorough with the Laplace transform of standard functions and the properties, you will be able to do inverse. You cannot get into inverse without knowing the standard forms and the properties. So now, so find the inverse transform of 1 by s plus 2, 3 by 2s plus 5 plus 4 by 3s minus 2. So look at the table. So what is if you say if you are given time valued function, you have frequency function. So the inverse, you will be given the frequency function, that is f of s, that is L of f of t. In inverse Laplace transform, you will be given f of s. You have to get back the time value function. So you will be given the second column. You have the second column, you have to find the corresponding function. So if you say Laplace of a is a by s, what is inverse of a by s? A. What is inverse of 1 by s minus a e power at? What is inverse of 1 by s plus a e power minus at? So same thing here. You see here 1 by s plus 2. If you take 2 out, whenever you have to make the coefficient of s should be 1. So take 2 out here. Here also take 3 out. So 1 by s plus 2 and here 1 by s plus 5 by 2 and here s minus 2 by 3. So 1 by s plus or minus a means it is exponential function. If it is 1 by s plus a, e power minus at. If it is 1 by s minus a, e power at. So what is it here? Here the a is 2. So e power minus 2t. And what is a here? 5 by 2. So 3 by 2 e power minus 5 by 2t. And what is a here? S minus a. So what is a here? 2 by 3. So for a positive exponential, e power 2t by 3. See, if you have s plus a, the denominator, it is negative exponential. If it is s, 1 by s plus a, negative exponential. 1 by s minus a, positive exponential. So that is why you have s plus 2 e power minus 2t. 3 plus 3 by 2 e power minus 5 by 2t plus 4 by 3 e power 2t by 3. So this is type 1, directly you can find the inverse. So you are given the frequency function, that is f of s, you have got the time function. Now next one, s plus 5 by s square minus 6s plus 13. Whenever you have a second degree function in the denominator, you try with completing the square, a minus b whole square or a plus b whole square. So s square minus 6x means you can guess that it is a minus b whole square. So what is s square minus 6s plus 13? What is half of 6s? It is 3. So s minus 3 whole square. So plus 2 square. See, if it is, you see, if it is, if you have a square minus 2ab form, it means a minus b whole square. What is b here? Half of 6x, that is 3. So s minus 3 whole square. A is s, b is 3. So s minus 3 whole square, what is it? S square minus 6s plus 9. But you have 13, so 13 is written as 9 plus 4. So s plus 5 by s minus 3 whole square plus 2 square. Now, see, the denominator and numerator should be of same function, either s minus a or s plus a. The denominator and numerator should be of same function. So you see the denominator, you have s minus 3 function. So numerator also you should simplify to the same. You see the denominator, you have function in s minus 3. So numerator also you should have s minus 3. That is why s plus 5 is written as s minus 3 plus 8. So split into two terms. So s minus 3 by s minus 3 whole square plus 2 square plus 8 by s minus 3 whole square plus 2 square. So Now it is of the form s minus a, and here also s minus a. Now you see the table. What is L inverse of f of s minus a? E power a t f of t. What is L inverse of f of s minus a? If you have s minus a function, shifting property, e power a t f of t. S plus a function, e power minus a t f of t. So s minus a function. So what is a here? 3. So e power 3t cos 2t, and here it is of the form a by s minus a whole square plus 2 square. So what is the exponential a? Exponential a is 3 and trigonometric a is 2. So exponential a comes from s minus a, that is 3, e power 3t, and it is of the form s by s square plus 2 square. So cos 2t. And here exponential a is 3. You ignore this 3, 2 by s square plus 2 square is sine 2t. So this completes the solution. I repeat, see, whenever you have second degree expression in the denominator, you should reduce it to a minus b whole square or a plus b whole square. Since you have minus sign, it will be a minus b whole square. So a is yes, and to find b, to know b, 2s equals 6, equate 2s equals 6, so s is 3. So yes, b is 3, so s minus 3 whole square plus 2 square. To know b, what you do is equate 2s to 6, this coefficient of s, so s is 3. So s minus 3 whole square, that is s square minus 6s plus 9. Now what you have, what is a constant? 13. So 13 you adjust. So what you have to do, you have to add 4 to 9 to get 13. So s minus 3 whole square plus 2 square. Now you see the denominator, you have function in s minus 3. So numerator also you should have the same function. So write s plus 5 as s minus 3 plus 8. See the denominator, you have s minus 3. Numerator also you should have the same function. So write numerator as s minus 3 plus 8. Then split into 2. Now after splitting, it is s minus a function in both. S minus a function in both. So if it is s minus a, it is e power a t f of t. If it is s minus a, what is a time function? E power a t f of t. So this a is from s minus a. So same thing here, a comes from, a is 3, so e power 3t. Here also a is 3, e power 3t. And then ignore this 3. S by s square plus 2 square is cos 2t. And ignore this 3. L inverse of 2 by s square plus 2 square is sin 2t. See the table. What is L inverse of s by s square plus a square? Cos 80. L inverse of a by s square plus a square? Sin 80. So that's what we have done here. So ignore 3, s by s square plus 2 square is cos 2t. L inverse of 2 by s square plus 2 square is sin 2t. Now we will see a similar problem. 7s plus 4 by 4s square plus 4s plus 9. Take 7 out. From, always the coefficient of s and s square should be 1. So take 7 out. 7 times s plus 4 by 7 by 4 times s square plus s plus 9 by 4. Now here you see it is a second degree expression. So you should get s plus a whole square. So what is that is you should get s plus a whole square. What is s plus, and 2s you equate it to 1. So what is the coefficient of s? 1. So 2s if you equate it to 1, s is half. So this is same as s plus half the whole square. So s square plus s, half whole square is 1 by 4. But we have 9 by 4. So what should be added to get 9 by 4? 8 by 4. I repeat, make the coefficient of s and s square as 1. So we have taken 7 and 4 out. Then see the denominator, it should be of the form a plus b whole square. So a is s, equate 2s to the coefficient of s, that is 1. So s is half. So s plus half the whole square. Plus what should be added to get 9 by 4? 8 by 4. So 7 by 4, so s plus 4 by 7 by s plus half the whole square plus 8 by 4. Then now you see the denominator, you have functioning s plus half. So numerator also you should have the same function. So add and subtract half. I repeat, see the denominator, you have s plus half. Numerator also you should have the same function. So add and subtract half, then you split into 2. So you have s plus a function. So what is the inverse of s plus a? F of s plus a, e power minus a t f of t. What is the inverse of f of s plus a? E power minus a t f of t. So you have e power minus half t. And what is this one? You ignore this half. What is L inverse of s by s square plus root 2 square cos root 2 t? What is L inverse of root 2 by s square plus root 2 square sin root 2 t? So you have you see here, what is L inverse of s by s square plus a square cos a t? L inverse of a by s square plus a square sin a t. So in place of a, you have root 2. That's why we have the answer. So first thing, write the exponential term. That is, what is a here? Half. So e power minus t by 2. And omit this half. So s by s square plus a square. That is cos a t. What is a here? Root 2. And a by s square plus a square. What is a here? Root 2. So to get root 2, we are multiplying, dividing by root 2. So 7 by 4 e power minus t by 2 cos root 2 t plus 5 by 4 1 by root 2 e power minus 2 by t by 2 sin root 2 t. Now next one, e power minus 4s by s minus 4 whole square. Now this is the next type. So whenever you have e power minus as, it means step function. I repeat, whenever you have e power minus as in the question, step function. So write the heavy side shift theorem. What is it? Laplace of f of t minus a, u of t minus a, e power minus as, f of s. What is the inverse? U of t minus a, f of t minus a. See, whenever you have e power minus as in the question, write the theorem. So what does it mean? It means inverse of e power minus as into f of f, u of t minus a into f of t minus a. So e power L inverse of e power minus 4s into 1 by s minus 4 whole square. What is a here? The exponential a, that is 4. So u of t minus 4, f of t minus 4. This is the answer for us. Now, you have to find f of t minus 4 through f of t. What is f of t? L inverse of 1 by s minus 4 the whole square. What is f of t? L inverse of 1 by s minus 4 the whole square. So what is inverse of 1 f of s minus a? What is inverse of f of s minus a? E power a t f of t. What is inverse of f of s minus a? E power a t f of t. So you have e power 4t L inverse of 1 by s square. Take this 4 out, e power 4t, omit this 4, so L inverse of 1 by s square. What is L inverse of 1 by s square? T. If you say L of t is 1 by s square, what is L inverse of 1 by s square? It is t. So you have t times e power 4t. So f of t is t times e power 4t. But what is what we have to get? F of t minus 4. So just replace t by t minus 4. So this completes the solution. I repeat, whenever you have e power minus as into something, write the property. So then take the inverse. L inverse of e power minus a f of a power minus as f of s is u of t minus a f of t minus a. So what is this a? Exponential constant 4. So u of t minus 4, f of t minus 4 is the answer. We have to find only f of t minus 4. How to get f of t minus 4 through f of t? What is f of t? L inverse of 1 by s minus 4 the whole square. What is L inverse of f of s minus a? E power a t into f of t. So e power 4t into L inverse of 1 by s square. So e power 4t into L inverse of 1 by s square. You omit this 4. When you take the exponential term, then in the inverse you should omit the constant. So e power 4t, L inverse of 1 by s square. What is L inverse of 1 by s square? What is L of t? 1 by s square. So L inverse of 1 by s square is t. So t times e power 4t. So this is f of t. So what is f of t minus 4? T minus 4 into e power 4 t minus 4. So what is the answer? U of t minus 4, t minus 4 into e power 4 times t minus 4. Now we have a similar problem, same type, e power minus as into something. So we are resolving into partial fractions. So the first factor a by s minus 1. Second factor, you have a second degree expression, bs plus c by s square plus 1. Find the constants a, b, c. Then find, after finding what is f of s, 2 by s minus 1, a is 2, b is minus 2, c is 1. So 2, what is f of s? 2 by s minus 1 minus 2s by s square plus 1 plus 1 by s square plus 1. So f of t is, take the inverse. What is the inverse of 1 by s minus a? E power t. What is the inverse of s by s square plus 1? Cos t. What is the inverse of 1 by s square plus 1? Sin t. You see the table. What is the inverse of 1 by s minus a? E power t. E power at. What is the inverse of s by s square plus a square? Cos at. What is the inverse of a by s square plus a square? Sin at. So you have inverse of 1 by s minus 1 e power t, inverse of s by s square plus 1 cos t, inverse of 1 by s square plus 1 sin t, because a is 1. So this is f of t. Now what is the answer? F of what you have to find? F of t minus 3. So what is f of t minus 3? Just replace t by t minus 3. So L inverse of e power minus a is f of s, f of t minus a, u of t minus a. So in place of a, e power minus 3s. In place of f of s, you have this function. So f of t minus 3, u of t minus 3. So f of t minus 3 is substituted. So this completes the solution. So here I have written the formula. You go through this. You should remember this. You should be thorough with the table, as well as if you have f of t, you should know to find f of s. If you have f of s, you should know to find f of t. You should remember in both the ways. You should by heart in both the ways. And I have shared some more in the one more table. Laplace of step function e power minus as by s. Yeah, inverse of e power minus as by s, step function. Inverse of e power minus as f of s, f of t minus a, u of t minus a. You know Laplace of periodic function. Inverse of this is f of t. Okay, so the inverse of s into f of s minus f of 0, f dash of t. So if you are given the right side, you should be able to write the left side. So with this I complete. If you have any doubts, you can ask me later.